Welcome to The Explainer, where we break down big topics in just a few minutes. So, today we're diving into an invisible force that literally shapes our entire world on a massive scale, the Coriolis Force.
All right, so let's jump right in with a puzzle that covers the whole globe. You've definitely seen this on the news, right? Hurricanes and cyclones always spin in a very specific direction, and it all depends on where they are on the planet. So, what's going on here?
It's this super consistent, super predictable pattern. And the answer isn't just the wind itself, it's something else, an invisible push that acts on it, deflecting objects to the right up in the northern hemisphere and to the left down in the southern hemisphere. Okay, to really get a handle on this, we've got to kind of shift our thinking about motion itself. It turns out our perspective, our point of view, is constantly in motion, even when we feel like we're standing perfectly still.
So, in the world of physics, there's a term for this, a non-inertial reference frame. And believe it or not, that's us. Because we are all standing on a planet that's spinning around once every 24 hours, we are all watching the world from a rotating point of view.
Now this is where it gets really cool. From our spinning perspective, things don't seem to follow the basic laws of motion perfectly. So to make all the math work, physicists introduced what they call fictitious forces, and the Coriolis Force is one of them. It's not a force like gravity, but a kind of phantom force, a correction factor that perfectly explains the motion we see from our spinning home.
You know what? Let's make this way easier to visualize. Imagine we shrink the whole Earth down to something much simpler, like a playground carousel. This is going to show us exactly how this illusion works. So picture this. You're standing still on the ground, not on the ride. You watch someone on the spinning carousel throw a ball to the person in the center. From your point of view, that ball flies in a perfectly straight line. Simple, right? Makes total sense?
But for the person on that spinning carousel, the experience is totally different. To them, that exact same ball looks like it's being mysteriously pushed sideways, curving away and missing its target completely. It looks like some invisible force is acting on it.
And that right there is the whole secret. The big reveal. The Coriolis Force isn't really a force at all. It's the curve you see because your point of view is spinning. The ball is actually flying straight. It's the thrower and the target who are rotating out from under it.
Okay, so now that we've got the carousel idea down, let's scale it back up to planet Earth and see just how huge the consequences of this effect really are.
Now, you're not going to feel this push walking down the street. It's way too weak for that. But when you're talking about massive distances and long periods of time, oh yeah, it becomes a huge deal. It dictates how huge weather systems spin, it drives the massive rotating ocean currents we call gyres, and it's even something that has to be calculated for long-range ballistics.
Just how big a deal is it? Well, get this. For a sniper taking a 1,000-yard shot, the Coriolis Force will actually deflect the bullet by 2.8 inches. That's more than enough to completely miss the target if you don't account for it. It's that real.
All right, this all leads us to a classic, famous myth that you've probably heard a million times. Does the Coriolis Force make the water in your bathtub drain in different directions depending on which hemisphere you're in?
The short answer? Nope. Absolutely not. While the force is technically there, it is just so incredibly tiny at the small scale of your sink that it's completely overpowered by everything else.
So, how do scientists actually know when the Coriolis Force is a big deal and when it's not? Well, they have a really clever tool for that called the Rossby number. It's basically a score that compares the system's own momentum against the strength of the planet's spin.
So let's just take a look at the numbers here, because they tell the whole story. For a hurricane, the Rossby number is tiny, something like 0.1. A small number means the Coriolis Force is in the driver's seat. It's the boss. But for a bathtub, the number is massive, like 10,000. That means the water's own tiny movements completely and totally overwhelm the Coriolis effect.
So, at the end of the day, what really makes your bathtub water swirl is, well, pretty much anything else. The shape of the drain, the way you pulled the plug, any tiny little swirl that was already there, all of those things are thousands of times stronger than the tiny push from the Coriolis Force at that scale.
You know, the Coriolis effect is just such a powerful reminder that our entire perception of the world, what we see as straight or curved, is totally shaped by our own motion through the universe. It really makes you wonder, what other invisible forces are out there, shaping our reality in ways we can't even perceive?